Hello. Today we're going to look at half-life and look at a simulation of half-life. Now what we have here is a radioactive element, polonium-211, and we're going to add some polonium-211 to our simulation. Half-life is how long it takes for half of the sample to decay. So for instance, I've got a pause down here, otherwise the simulation just starts immediately. I'm going to add 10 polonium-211. I'm going to add 10 more, 30, 40, and then 50. And I'm going to hit this little button down here that says step. And that will show that we have 50 of the polonium up there and 0 of the lead-207. So our polonium is going to change. It's going to go through radioactive decay. And that change, it will release some radiation. So I'm going to show the simulation, and you'll see when we run the simulation, some of these start giving off radioactive particles. It's alpha decay. And each time they give off one, it changes to lead-207. And that's what we're seeing up here. Every time it changes to a lead, we see it drop down. And then it gives our running totals of each one as it goes. So right now we've gone a second and a half. We're almost 2 seconds in. And all of this polonium-211 is changing to lead-207. So that's radioactive decay. That's what we're seeing here. Now I'm going to pause this again. I'm going to hit the step button, which should reset it. Oh no, I'm sorry. Reset all nuclei, and then hit the step button. So now I've got 50 again, 50 and 0. So we're going to run this through, and we want to take down the data. Now at the half-life, if I have 50, and half of it's going to be gone at the half-life, that means I should have 25 left. But this is just on average. So let's run it and then pause it at the half-life. So we're running it, and once it gets to this half second, at that half-life, I'm going to pause and see what our number is. Right there. So it looks like it's 26. Now, statistically, it should have been 25, but that's the whole point. It's an average. The next half-life is at 1 second. Now that means of the 26, 13 should be left because half of it will have gone through radioactive decay. So let's see where it goes to. And at 1 second, I'm going to pause it again. Okay, so instead of 13, I'm at 11. Again, close to what the statistical average should be. You're going to be running this same simulation with 50 of the polonium elements, okay? And I'll show you how we're going to do that and what numbers you need to copy down. So it's this paper here that you're going to write your data down onto. In the data table, I've already given us the time intervals that we just saw, 0 seconds, 0.5, which is our first half-life, 1 second, 1.5, 2, 2.5, and 3. The half-life is it's a half a second. So every half second is another half-life, okay? All we're doing is writing down how many polonium-211 are left at each interval. So when we start off at 0, we're gonna have 50, okay? Let's run the simulation and I'll mark down each one as we go. Okay, so first thing I want to do is reset all my nuclei here. I hit this step button and it shows that we're going to start with 50, which is what we wrote down. So press play. I'm going to stop at the first half-life, which is half a second. And that's good, I'll pause there. And right now we're right at 25. So I write 25 down under the half second. And then I keep going. and we'll stop at the next half-life, which is 1 second. Okay, this one, at 1 second, I'm at 15. I'll pause again at 1.5 seconds. I'm gonna have to judge it as best I can. Probably right about there. At 1.5 seconds, I'm at 11 polonium-211. So it just keeps, the number of those keeps getting smaller as it goes through radioactive decay. At the 2 second mark, I'm going to pause and write down 4, because I've got 4 left. And then I'll do 2.5 and 3. Looks like 2.5, I'm at 2. And at 3, I am still at 2. Now, the simulation will keep going, but we only went out to 3, and that's okay. You can see that the simulation, there it goes, finally shuts off. Sometimes it'll end before it gets to 3 seconds, sometimes it'll end after. Radioactive decay is an average of how long it takes for half of the material to go be converted by giving off radiation or radioactive material. So the last thing I want to do is I filled in my data table. Now I'm going to graph this. And on the bottom is going to be our time in seconds. I'm going to start at 0 and then half a second, 1 second, 1.5, 2 seconds, 2.5, and 3. And on our vertical axis, our y-axis, is the number of polonium-211 atoms. Now we start at 50, so I'm going to go 0, 10, 20, 30, 40, 50. And now I'm going to graph what I have here. So at 0 seconds, I started with 50. The first half-life, which was 0.5, I had 25. At 1 second, I had 15. 1.5, I had 11. At 2, I had 4. 2.5, I had 2. And at 3, I also had 2. And you'll see it makes this nice curved, line. Now you're going to do the same thing 2 more times. So you're going to run the simulation the exact same way, collect your data, graph it the same way. You're also going to do that on this second page 1 more time. And then you have an analysis at the end. So let me know if you have any questions. There's lots of information on half-life online on YouTube as well. Finish up your graphs and the analysis, and that'll be that. Thank you.